All right, hello again. I'm back. What I thought was going to be a small break turned into a very long break, doing other things. So I'm going to go back to what we were just looking at here on the slide. So it backed up to slide 9 again. Just taking a look at that, you can see what I had before. We have our two statements. Tuesday comes after Monday. We'll call that P. Wednesday comes after Monday. We'll call that Q. Either of those statements can be true or false. So too can the two of them together, P and Q, which is really the conclusion of our sample argument. So it's either true or false that Tuesday comes after Monday and Wednesday comes after Monday together. We're going to see more about this in chapter 3, where we talk more specifically about logical operators and how complex statements get formed. But for now, let's just keep working through it. So each of these statements is true or false. Any simple or complex statement is either true or false. And truth tables are helpful precisely because that's what they show us. They're just showing us the combinations of truth and falsity that different statements in an argument might have. And a full or long truth table, which is what we're going to be looking at constructing now in chapter 2, we're going to be using those in chapter 3, and in chapter 5, we're going to look at them in terms of how they can help show us whether or not an argument is valid or invalid. They just show us all of these possible combinations of true and false. So a truth table for just one value, one statement, is very simple. It just looks like this. The very top row, the row that has the shading, it has P in there, that's what we call the header row. That just tells us what the column represents. And the column is the vertical thing on a table. In this case, we have two rows under the header row. So we've got the header row up top that says P. This is telling us that that's what we're seeing in the rest of the column. We've got two rows under it. One has T, one has F. The T just stands for true. The F stands for false. So that's all this looks like. We're going to look at a more complex one, just that represents the argument we've been looking at. There's an even more complex example in the book. If you look at section 2.4, I highly recommend reading through that after watching this video and reading through sections 2.1, 2, and 3. So let's just talk through this argument we have. So this argument we had, just dealing with days of the week. Tuesday comes after Monday, Wednesday comes after Monday. So it's true both that Tuesday comes after Monday and Wednesday comes after Monday. Now, if we take a look at what we have here, ultimately what we are looking at are columns and rows that represent these various possibilities. So, like I said, columns run up and down on a table, rows run horizontal. So columns are vertical, rows are horizontal. I feel like I'm trying to do some kind of dance or something. So on the table that's up right now, I've added an extra column and an extra row just for explanatory purposes. So when I actually go to make a truth table, it won't have the very top row that has an empty cell and that says column 1, column 2, column 3. You also won't have that leftmost column that is the empty cell and then header row, row 1, row 2, row 3, row 4. Those are just there for explanatory purposes. A cell is an individual little box in one of these tables. So you can locate a cell by its column and row number. So the very top left cell, the one that's empty, that's in the first column in the first row. The first row runs across the top. So from there, we could go over from each column and take a look at that, or go down each row. So for instance, where it just says Q, P2, that one's really, we could identify that by column or row. I was about to do it, but it might be a little bit confusing in part because I've got the columns labeled a little bit differently just for the explanatory purposes. So we got the header row. You can see that indicated. It's really the second row down. It's only the second row right now because we've got the top explanatory one. But the header row will be the top row. And I'll always try to bold it or do something with what's going on in that row just so you can see that it's a little bit different than the other ones. It also has the premises and conclusion labeled. So in this argument we've just got P and Q, and that's premise 1 and premise 2. And then the conclusion is just asserting P and Q together. So the ampersand, the and sign. That is one of the logical operators we're going to look at in the 3rd chapter. And like I've already mentioned, all it really tells us is that both of the simple statements it connects are true. Now, under that header row, so the four bottom rows, the ones labeled row 1, row 2, row 3, row 4, they've got T's and F's in them. And so what you can do is you can look at column 1, that's the one with P in it, and up in the header row, it just tells you what the rest of the column represents, when in this case is just P and its possible truth values. And then in the different rows, in the first 2 rows, P is true, in the last 2 rows, P is false in that column. Now the way we actually read a truth table is by reading across each row, and what each row shows us is a different possible combination of the truth and falsity of the simple statements in the argument. So what does that mean? Well, in this case, we only have 2 simple statements, P and Q, and what we see are 4 possible combinations of the truth and falsity of P and Q. In row 1, both P and Q are true. In row 2, P is true while Q is false. In row 3, P is false while Q is true. In row 4, both P and Q are false. That is all the possible combinations of P and Q being true or false and taking them together. So when you look at row 1, and we just look at P and Q, just ignore column 3 for the moment, we see true, true. Row 2, we see true, false. Row 3, we see false, true. Row 4, we see false, false. Those are the only 4 possible combinations. Now what these 4 rows are representing are 4 different possible scenarios, right? Assume we don't know if P or Q is actually true. We need to figure that out, right? Now, of course, for this example argument, it's pretty obvious that both P and Q are true, but set that aside. What the truth table is trying to do is help us determine whether or not the argument is valid or invalid, and that depends on its structure, not the content. It doesn't really matter whether P and Q are true or false when we're trying to figure out if an argument is valid. What matters is how the possible combinations of the truth and falsity of the simple statements relate to the truth and falsity of the complex statements, and how the premises and the conclusion relate to each other. We're going to have to revisit this in chapter 5 in particular, but ultimately we're trying to explore all the possible combinations of truth and falsity. So the different rows represent different possible combinations. That's ultimately what we're doing. And in a truth table like this one, we're trying to exhaustively check all the possible combinations. So that's what we have here. In column 3, we also have P and Q together, and you see it's labeled true in the first row, but then false, false, false. The reason it doesn't follow the same kind of pattern that P and Q do is because whether or not P and Q together, that complex statement in column 3, whether or not that statement is true depends on whether or not the simple statements that make it up are true or false. We're going to have to see this in chapter 3. That's where we're going to look at operators and learn a lot more about this. But just keep that in mind for now. So what we're going to do in the rest of this chapter is take a look at how we make this table. So this is the table that represents the argument we're dealing with. How do we get here? That's what we're going to take a look at. So we need to think about a few things. How many columns should our truth table have? The truth table we have here is 3. Why does it have 3? Well, a truth table has a number of columns equal to the number of the simple and complex statements in the argument. In this case, we had P, we had Q, so there's 2 columns, and we have P and Q together. So that's a total of 3 columns. That's why we have 3 in this argument. You might have more columns. Very often you'll have more than 3. You'll very infrequently only have 2 columns. In fact, I'm having trouble thinking of a scenario where you would only have 2. So you'll probably have at least 3. You might have several, and we'll see that as we move along. Now, the truth table starts with the header row. Like I said, the top row that represents all of your different statements, both simple statements and complex statements, in separate columns. We then also have to figure out how many other rows the truth table has, and this will always be 2 to the n, where n is the number of simple statements in the argument. Now, the number of rows we calculate this way is always in addition to the header row. The header row is, in some sense, special. It could even be helpful if I just didn't call it a header row, but it's special. We always have a header row, and then we figure out how many other rows we need by calculating 2 to n, 2 to the power of n. N is the number of simple statements in the argument, not complex statements, just simple statements. And we figure out how many simple statements an argument has by translating the argument into simple statements and assigning each of those simple statements a different letter. So it's really a question of how many different letters are there when you have translated the argument. Take that number, then put 2 to the power of that number. So if you had 2 simple statements, it would be 2 to the power of 2. If you've got 3 simple statements, it would be 2 to the power of 3, and so on. Whatever that result is, you add that many rows to the table. So there is a straightforward progression to the number of rows a truth table can have. So depending on the number of simple statements, just say 2, 3, 4, 5, or 6, we're not going to be dealing with arguments that have only one simple statement. And in some ways, you almost can't have an argument like that, but it gets a little bit technical. Let's leave that aside. We're not going to deal with arguments with more than six simple statements for the sake of putting together a truth table like the one we're looking at. So if you've got 2 statements, there's a question, how many rows are we going to have? So it's going to be 2 to the power of n. N is always equal to the number of simple statements. So if we've got 2 simple statements, well, that's the argument we're looking at. We've got 4 rows. 2 to the power of 2 is 4. We have 3 simple statements. Think about that for a second. 2 to the power of 3, what's that? 8. And you see this progression. So every time we have one more simple statement, we double the number of rows. So if we've got 2 simple statements, we get 4. We have 3 simple statements, we get 8. If we have 4 simple statements, we get 16. There are 5 simple statements, we'll have, think about it, 32. And if we have 6 simple statements, we're going to have 64. Now, I didn't put it here, but if you have 7 simple statements, that's 128 rows. If you have 8 simple statements, that's 256 rows. And you have 512 rows, 1,024 rows, so on and so on. I'm not going to make you construct a truth table with 1,024 rows, so don't panic. At most, I could see asking you to construct one that has 32 rows. And just a suggestion for the homework assignments that ask you to make a truth table, try to pick an argument that only has maybe 4 simple statements. Try to keep it relatively straightforward, like in all the other homework assignments. I don't want to see a homework assignment that has 1,000 rows on it. You don't want to make one, trust me. So try to keep it simple. So we always have this progression in terms of the number of rows. So on any truth table, except the short one, we're going to take a look at the short truth table method in chapter 6. But the sorts of truth tables we're making now that exhaustively show us all the possible combinations of true and false always have this one of these number of rows. There'll be 4, 8, 16, 32, 64, 128. There just aren't truth tables with 17 rows. Unless you're using the short method, which is a kind of exception, it works a little bit differently. We're going to set that aside until chapter 6. So for what we're doing now, you're always going to have 4 rows or 8 rows or 16 or 32. Note, a truth table can have any number of columns. The number of columns just depends on how many simple statements you have, so many different letters you use, plus all of the different complex statements. So all the different ways that simple statements comes together. We're going to look at that more in chapters 3, 4, and 5. Okay, so in 2.3 of the primer, there are basic rules for truth table formation. There are several rules. We're going to walk through them. We're not going to be able to finish the last one because we need to understand all the information in chapter 3 to be able to follow the last rule. So in some ways, chapters 2 and 3 really fit together because we use what we learn in chapter 2 to understand logical operators and complex statements in chapter 3. And it's only by understanding that information in chapter 3 can we finish making the truth tables that we start making in chapter 2. So the first step in creating a truth table is just to identify all the simple statements in the argument, right? So this example argument we're using has 2 simple statements. Tuesday comes after Monday is one. Wednesday comes after Monday is the other. We can represent those just with the letters P and Q. So we've done that. We've identified all the simple statements. There are 2. That's it. The next step, we create a header row. Starting at the left, create a column for each simple statement in the argument. So we're just starting with simple statements for the moment. In this case, we just have a column for P and a column for Q. We have two simple statements, that's it. So we make one column for each of them. Next, number 3, we add columns for each complex statement to the right of the columns that represent our simple statements. So in this case, we only have one complex statement, P and Q. So we already had P in one column, Q in another column, so we just add another column for P and Q together. All right, so we just have 3. Yeah, you can probably see how we're already building up towards that full table we already saw. Now, depending on the number of simple statements and complex statements we have in an argument, we might have virtually any number of columns. Here again, just for the sake of giving you manageable things to do, try not to ever give you a question that makes you do 20 columns or something like that. Depending on the argument you find and how complicated it is, you might have very few columns, you might have several columns. One somewhat nice thing is that no matter how many columns we have in our truth table, we're always going to have some set number of rows, 4, 8, 16. And then filling in the values in the columns will just depend on the values we fill in the rows, on the simple statements, I mean. So we'll come back to that. Okay, step 4. Label each premise and conclusion in the header row of your truth table. In the truth table we have, in this argument we just have 2 premises and a conclusion. And so each item in our header row gets labeled. This won't always be the case. There will be times where you have an argument and you have to label the premises and the conclusion in the header row, but it's not going to wind up labeling everything that's there. So you might have P and Q and R and a few complex statements, and you only actually wind up labeling, say, 3 different things in the header row, even though you've got 6 columns. And there just is no rule about precisely what it is in the header row you're going to label. It all depends on what is in the argument to start with. This will make more sense as we start looking at more examples as we move along through the course. But just keep in mind that ultimately you want to do this. So these first 4 steps can often be condensed in together when you take a look at an argument, figure out how many simple statements it has, look at how many complex statements it has. You'll add those up together. So if you have, in this case, your 2 simple statements, 1 complex statement, you need 3 columns, 1 for each different kind of statement. And as you're making that row, that header row, you can be inserting the premises and the conclusion as you go. Just label it. But that, you can still just follow these steps. If you follow these steps, you'll always get it right. Once you have a good handle on precisely what you should be doing here, often you can do these things all together. So for instance, when I'm making a truth table, I don't actually do step 1, step 2, step 3, mentally, saying, okay, that's what I'm doing. Although I'm going through those steps and then I'm just producing the row as I need it. Okay, step 5, determine the number of rows your table will require. And this is just what we were already talking about. This will always be 2 to the number of n. N is the number of simple statements in the argument. Right? Our sample argument here has 2 simple statements, so we need 4 rows. And always remember, this calculation is producing the number of rows in addition to the header row. The header row is something separate. It's there by default. Every truth table has a header row, no matter what. It's all a question, how many extra rows do we need? Right? And even then, when we're talking about just rows on their own, unless we specifically talk about the header row, we're really talking about the rows below the header row. So in this case, we need 4 rows. So we're going to have a table that suddenly looks like this. Right? There's our header row up top. What we did in steps 1 to 4, we've got P and Q, P and Q. We've got 3 different columns for them. We've labeled them, premise 1, premise 2, conclusion. Now we've added in 4 empty rows at this point below the header row because we have 2 simple statements, which tells us we need 4 rows. So that's what we've done now. Now that we have those empty rows, we need to figure out how to fill them in. We need to enter the truth values in the cells in each column that represents a simple statement. So in this argument of ours, just backing up for a second, we need to fill in the column 1 and column 2 that represent just P and Q on their own. That's what we're trying to figure out in step 6. Just the columns that represent simple statements. So we need to do that. But to be able to do that, we need some sort of procedure because we want to make sure we get it right And we want to make sure we always have every possible combination of truth and falsity for the two simple statements represented on our table. So there's a procedure to do this. There's two ways of going about this. It will result in the same product. You can follow either of these ways, choose whichever one seems easier to you. If you want to check your own work, if you remember both ways of doing it, fill in the table one way and then just work backwards with the other method just to see if you get the same result. So it's these two columns we need to fill in, the ones that just got shaded green, P and Q. How are we going to do that? Well, like I said, we've got these two ways, right? We want every possible combination of the simple statement's truth values represented on our table. So there's these two approaches, two methods that we can use. Either of them is perfectly fine. The first method works like this. First, we start in the leftmost column, right? And which will always be a simple statement, because when we're making our truth table, we start by making columns for the simple statements on the left-hand side of our table. So we start with the leftmost column, whatever our very first simple statement is. We fill in the first half of that column with T for true. The second half of that column we fill in with F for false. So in the cells, we fill in true, true, false, false, depending on how many statements we've got. We then move to the next column to the right. We fill in half as many rows with true and half as many with false, but we double the number of times we do this, so the whole row still gets filled up anyway. The third step is really just to repeat step 2. We continue filling in trues and false in each column until we've completed the truth table. Now, I want to pause just for a second again here. So I'll be right back. If there's a little hiccup in the video, my apologies. All right, hello again. Just going back to what we were looking at. Just as I was looking at it, I realized that it should be worded slightly differently. So I just backed up to this first method, just reworded it a little bit. I'm sorry that there's this sort of a little bit of inconsistency in the video. One shortcoming of my current arrangement is I don't really have good video editing software. So whenever I do something silly, unfortunately, you're just gonna have to live with it. Because ideally I would go back and cut out that stupid thing I just did, but I can't. I could just sort of scrap this entire video and start over, but that would eat up an awful lot of my time. And frankly, I'd rather just do a few embarrassing things and ask for your patience rather than spend about 6 times the time. See, right? Silly again. 6 times the amount of time, that's very awkward. Putting together the video to make sure that there aren't any little hiccups in it. Unfortunately, I just make mistakes sometimes. So I backed up. I've just taken the wording directly out of the text I've given you to help make this first method a little bit more clear. So when we're looking at how to fill it in, same thing. The first step is the same. We start with that leftmost column. That's going to be a simple statement. We fill in the first half of the rows with true and the second half of the rows with false. We're going to take a look at how to do this in just a second. So just walk through this. The second step, for every column we move to the right. So we start in the leftmost column, we fill in half true, half false, and then move over one step, one column. Now, we have the number of trues and falses that we enter each time, but we always fill the column, and so the end result is that the column is always full of trues and falses, right? The very last column, representing a simple statement, which we'll start at the left with a simple statement column, we'll then move over simple statement columns. Eventually we hit the last one before we hit complex statements. The very last one is always going to alternate true and false. We continue the process outlined in 2 until we're done filling in all the simple statement columns. Right? So what does this look like in practice? Let's take a look. So remember, we start on the leftmost column, we fill in half true, half false, we then move over, we put in half as many true and false at a time. We keep moving over, having the number of trues and falses we put in at a time, but making sure we fill the row. Eventually, we end up just alternating. True, false, true, false, true, false. So here's that example argument we had again. We've just got P, Q, and P and Q. The leftmost column represents P, a simple statement. So we start by filling in the first half of the rows with true. We've only got 4 rows, so in this case, that's 2 trues in a row. We then put two falses in a row right after. So now we filled up the first column. The first half of that column is true, second half of that column is false. We then move one column to the right. We still have a simple statement, Q. We have the number of trues and falses that we put in at a time, but we still fill the column. So we were putting in 2 trues and 2 falses to start with. We now cut that in half. What does that leave us with? Just one at a time. So in the Q column, we start with true in that first row. And see, this is, like I said, the header row in some sense, don't consider that the first row on the table. It's its own special row. So really the first row we're interested in is this one right under the header row. So in the first row we have true, and then we immediately go to false. Then we put in true again, and then we go to false. We've now filled in the values for the simple statements on the table. If you have a truth table that only has 2 simple statements, it will always have 4 rows, and under the simple statements, no matter what they are, they can be P, Q, B, T, F, whatever, doesn't matter. Under those, it's always going to look like this. You're going to have true, true, false, false in the first column, true, false in the second column. That's just automatic. So there are certainly parts of what we're learning you can just learn strictly by memory. This is one. That's just always what the simple statement columns in a truth table with only 2 simple statements is going to look like. So we've done the first method. What's the second method for filling in the truth values of the simple statement columns? Well, in many ways, it's just the opposite. It just works backwards. So what we do is we start in the rightmost column, and we just start by, we start at the end with what we did before. So we just go true, false, true, false, true, false, true, false. No matter how many rows we have, we just alternate between trues and falses. Then we move to the next column to the left. Right? So in the first method, we start at the left and move towards the right. In this method, we start at the right and move towards the left. Every time we move a column to the left, we double the number of trues and falses we put in at a time. Right? And we just keep putting them in until we fill the cells. And we just continue this process. We then move another step to the left. We double the number of trues and falses we put in at a time, make sure that we fill the whole column. And we just keep doing it until we run out of columns that represent simple statements. So let's take a look at how we do that. Now, remember, we're filling in only the truth values of the simple statements. So in step 1, where it says start in the rightmost column, that's the rightmost column representing a simple statement. So let's take a look at that. So if we look at our table again, we've got our 3 columns. The rightmost column that represents a simple statement is Q. Right? So we start just by alternating. We go true, false, just like we said. Right? And that was the last thing we did in the previous method. So this is really just that first method in reverse. So we've started in the rightmost column that represents a simple statement. We've just alternated true, false, true, false. Now we move a column to the left. We double the number of trues and falses we put in at a given time, which in this case, we started with 1, 1, 1, 1. So now we go 2, 2. But that's all we need. If we had a larger truth table, we might have to go 2, 2, 2, 2. But we only have 4 rows. So we're just going to put in 2 trues and 2 falses. And we're done. We've filled in all the values for the simple statements. Right? We have the same result. We still have under the P, in the P column, we still have true, true, false, false. Under the Q column, we have true, false, true, false. And with that combination of truth and falsity, we have every possible combination of P and Q being true or false together. So in the first row, we see them both true. In the last row, they're both false. The 2 rows in between show us instances where one is true and the other one's false. If we had 3 values, we're really looking for the same thing. We're looking for every combination of how they could be true or false. So in the very first row, they'll all be true. In the very last row, they'll all be false. And every row in between is some combination of them. Now, we can move on to the 7th step in creating a truth table. That is to enter the truth values of complex statements. So in that example we have, that's just going to be the P and Q row. But to do that, we have to learn about logical operators. That's what we need to do in the next chapter. Because we need to figure out how to make complex statements in this artificial system that we're using. To do that, we have to understand what operators are and how they work. And to really learn about that, we're going to be using truth tables. This is part of why we spent time here in chapter 2 trying to figure out what's going on in the truth table to start with and how to start making it. Now that we know how to make most of it, but not all of it, we can move on to taking a look at that last column. So just taking a quick look at our table again. Sorry for the brief pause again. I'm still getting the hang of this. Please bear with me. So if we just look at our table, what are we left with? What haven't we filled in? The very last column. And that's the column that represents the complex statement. And in this case, the complex statement is just P and Q, just saying that both P is true and Q is true. That's really all P and Q means. So we're going to see how to do that in chapter 3. The AND is one of the 5 basic operators we're going to look at. We only need those 5 operators, and with a few more rules about how we can use them to link together simple statements, we can then do all sorts of very complicated and interesting things with very few underlying resources. This is one of the advantages to learning this sort of artificial system. With a very minimal amount of rules and what you can do, you can stitch together all sorts of different statements to have all kinds of different meanings, but you can still take a look at how the truth and falsity of particular statements bears on the truth and falsity of other statements. Ultimately, that's what good argumentation is all about. So we've now gone through the material I've got here for chapter 2 in terms of the instruction. I hope this has been clear. I hope the video has been of sufficient audio and visual quality. If there's been any issues with it, please contact me. Take a look through the readings. Do those readings diligently. Watch this video more than once if you need to. And if you still have questions after going through the material, taking a look at it, thinking about what's going on, if you've got questions about the basic steps we've looked at here, and just for what's going on in a truth table, feel free to contact me. More pieces of this puzzle are going to be coming in the videos and material for chapters 3 and 4 and 5. So you're going to see by the time we're done chapter 5, we have all sorts of interlinking parts that will have come together by that point. Until we get there, what we're doing is sort of seeing all of the different pieces of this interlinking system come together. So chapter 1, we were dealing with part of it. Chapter 2, we're dealing with another part. 3 is dealing with another part. 4 is dealing with another part. Chapter 5 is where we sort of take all of this, pull it together, and finally do something with it. We've got a tool we can use by the end of chapter 5. Chapter 6 shows us a more efficient way to use that tool, but we need to understand how to use it before we can get there. So I'll go ahead and end this video here. I suggest trying the practice questions at the end of chapter 2. If you have trouble answering any of them, review the relevant material. You can expect some questions like this to show up likely on the exam, or if there aren't questions just like this on the exam, or whatever precisely we're going to do at the end of term, which I'm still working on as of making this video, you're certainly going to need to understand how all these things work to be able to complete the assignments going forward. So I hope you've enjoyed this video. I hope you are all well, and I hope the transition to this new format isn't throwing things for too much of a loop, and I hope it's not going to interfere with my ability to deliver clear explanations of the content as we move forward. So I hope you've enjoyed the video. Have an excellent day, and I'll be posting some more material on Friday.